In this, the second in a series of training videos, we're going to look at how to set up your Indra Smart Pro charger that we installed in the previous video. And we're going to really focus in on earthing arrangements. At this point, it's important to note that this is a training video for experienced, qualified electricians, not a DIY video for homeowners. This is a complex and potentially dangerous area of electrical installation, requiring the use of calibrated test equipment and not something that should be undertaken by amateurs. Okay, so you've looked at the incoming supply and verified its suitability, you've selected a location for the charger, and you've selected the correct type of RCD. If you haven't done any of this or understand the significance of why to do it, then it may be time to go and watch the first video in this series. Now in this video, we're going to look at why the earthing arrangements for an EV charger is so critical. We find some information about this in Regulation 722.411.4.1 under the heading TN Systems, where we read, "A Pme earthing facility shall not be used as the means of earthing for the protective conductor contact of a charging point located outdoors or that might reasonably be expected to be used to charge a vehicle located outdoors unless one of the following methods is used." Now we'll get to those methods in just a moment. But first of all, why is this regulation in here? Why are we worried about Pme earthing for charging EVs? Well, first of all, let's remind ourselves what a Pme earthing arrangement is. In a TNCS system, the connection with earth is brought to a property by combining it with the neutral conductor. Once it reaches the building, the neutral and earth conductors are split and then remain separate within the electrical installation. And that's where we get TNCS from. Terra, or earth, and neutral, combined and then separate. Now, if we lose that combined neutral and earth connection in the supply cable, then a big problem occurs. Basically, because the current no longer has a return path, the voltage on the neutral rises to 230 volts, and because the neutral and earth are connected at the origin, all the exposed conductive parts that are connected to the main earthing terminal in the property will rise to 230 volts as well. Now, if someone touches an exposed conductive part and makes a connection to the literal earth that we walk around on, then this could well be enough to give them a lethal shock as the current finds its way back to the transformer down the road. Inside a property, the only place that this is likely to happen is if you touch a metal object that has a good connection to the literal earth, like say an incoming water or gas pipe or a piece of structural steel that is embedded into the ground. And that's why we connect these items to the main earthing terminal of a property via a bonding cable. It's not in case the pipes become live, it's to make sure that they do become live in this type of event. If every piece of metalwork that can be touched at the same time becomes live at 230 volts, then there's no difference in voltage between them and you can't get a shock if you touch them. So if I have 230 volts in my left hand and 230 volts in my right hand, there's 0 volts difference between them, hence no current flow and no shock. To try and minimise the chances of losing the combined neutral and earth connection outside the property, there's a couple of precautions that the DNO take. One is to use a concentric cable where the line conductor is in the middle of the cable and the combined neutral and earth is wrapped around the outside. This means if anyone accidentally cuts through the cable with, say, a shovel, the line conductor is likely to be disconnected before the neutral and earth, meaning that the metalwork in the property won't go live. Another precaution is that along the length of the supply cable, the combined neutral and earth is physically connected to the literal earth that we walk around on via electrodes, or rods as we call them, along its length. This precaution is what's called protective multiple earthing, or PME. But what has this got to do with EV charging? Well, one issue is that the only place that one of these PME rods is actually installed and connected is where the supply cable to a property comes off the main cable in the road. They're not really installed along the length of the standalone cable to your property. So if the combined neutral and earth connection in the torpedo joint in the road becomes disconnected, and this does happen sometimes, then we've got a big problem as all the exposed conductive parts of the installation become live. Now, inside the building, a person probably won't have a good connection to earth, and anything that brings an earth connection into the property is bonded, so there's no massive drama there. However, a person stood outside on the actual literal earth may well have a decent connection to the planet, and if they're stood by a massive piece of metal that's just become live at 230 volts, like a charging electric vehicle, that person is about to have a very bad day if they touch that car. And it doesn't need to be a great connection to earth either. 50 milliamps of current for 50 milliseconds is enough to kill a person. And also, no RCD currently available will detect this problem and disconnect the circuit. So it's with good reason that BS 7671 says we can't supply an EV charge point for charging a car outside with a cable relying on a Pme arrangement for its earth connection. But enough about the problem. What's the solution? Well, the simplest option is to install the charging point in a position where the car can only be charged indoors, such as a garage or similar. Of course, this is not always going to be possible or indeed enforceable. So under the original version of the 18th edition, many installers opted to disconnect the connection from the Pme to the charging point and instead connect the earth terminal of the charging point to an earth electrode. However, hammering an earth electrode into the ground is fraught with hazards from hidden services such as gas, water and electricity supplies, and achieving a low enough resistance is also challenging. So BS 7671 allows for some other options instead, and indeed it was the proliferation of solutions to this very problem that triggered the issuing of Amendment 1. And Amendment 1 contains this interesting point in Note 6, where we read: creating a TT earthing system for charging equipment or the whole installation as an alternative to using a Pme earthing facility with one of methods 1 to 5 above may not be an appropriate solution due to the inability to provide sufficient separation from buried metalwork connected to the supply pen conductor. So we're being very much discouraged from using an earth electrode in the way just outlined. The reason for this is that if the earth electrode for the charging point goes into the ground just next to a piece of earth metalwork from the building, such as a gas or water pipe or structural steel, then it's possible the electrode could be so close to that bonded metalwork that in the event of losing the combined neutral and earth conductor to the property, the earth electrode could become live due to touching or even just being in the proximity of the building metalwork. So it's pretty clear that we're being discouraged from using an earth rod for this reason. However, there may be another reason to use an earth electrode, as we'll see a little bit later. Okay, so enough about the problem, let's talk solutions and how the Indra Smart Pro can be used in this regard. Indra use a proprietary solution they refer to as PESTS that addresses the most common problems in EV charger installation. PESTS is an acronym for pen fault, earthing, simultaneous contact and touch voltage. So let's look at how the Smart Pro charger addresses these issues. In the back of the charger here, there's this little selector switch that changes the function of the charger from what's referred to as mode A to mode B. Now this is nothing to do with mode 1, 2 or 3 charging or anything like that. It's to do with how the requirements for regulation 722.411.4.1 are met. As stated earlier in the video, that regulation reads: a Pme earthing facility shall not be used as the means of earthing for the protective conductor contact of a charging point located outdoors or that might reasonably be expected to be used to charge a vehicle located outdoors unless one of the following methods is used. First of all, we need to bear in mind that this is referring to a TNCS system using protective multiple earthing. Therefore, if you're connecting to a TNS or TT system, then you don't need to apply any of the indents that follow. And critically, the switch on the charger PCB must be set to mode A. But what about those Pme systems? What changes then? Indent 1 states that you can connect an EV charger to a Pme system if the charging point forms part of a 3-phase installation that also supplies loads other than for electric vehicle charging, and because of the characteristics of the load of the installation, the maximum voltage between the main earthing terminal of the installation and earth in the event of an open circuit fault in the pen conductor of the low voltage network supplying the installation does not exceed 70 volts RMS. So an example of this would be perhaps a commercial installation with a 3-phase supply to the property. Under this circumstance, the mode switch would be set to A again. Indent 2 gives us another example of acceptable use if the main earthing terminal of the installation is connected to an installation earth electrode by a protective conductor complying with regulation 544.1.1. The resistance of the earth electrode to earth shall be such that the maximum voltage between the main earthing terminal of the installation and earth in the event of an open circuit fault in the pen conductor of the low voltage network supplying the installation does not exceed 70 volts RMS. Again, if you're installing a charger in this scenario, then you need to set the switch in the back to mode A. All the scenarios discussed so far have two things in common. Number one, they are not the most common types of situation where you'll be installing an EV charge point, and two, they do not require the use of a reference earth electrode. Now, what is an earth reference electrode, I hear you cry? Well, let's look to the next indent to give us a clue. It states, protection against electric shock is provided by a device which electrically disconnects the vehicle from the live conductors of the supply and from protective earth in accordance with regulation 543.3.101 indent 2 within 5 seconds in the event of the voltage between the circuit protective conductor and earth exceeding 70 volts RMS due to an open circuit fault in the pen conductor of the low voltage network. The device need not operate if the voltage exceeds 70 volts RMS for less than 4 seconds. The device shall provide isolation and be selected in accordance with table 537.4. Closing or resetting of the device shall be possible only if the voltage between the circuit protective conductor and earth does not exceed 70 volts RMS. Equivalent means of functionality could be included within the charging equipment. So, to translate, in this method, a device monitors the voltage between the circuit protective conductor of the EV charging unit and earth, remembering that is the literal earth that we walk around on. Now this makes sense because the CPC of the circuit is effectively connected to the bodywork of the car. So what this method is doing is measuring the voltage that could reasonably be expected to appear across a person touching the car and the literal earth. If this value goes over 70 volts, it will disconnect the circuit in less than 5 seconds. You'll see this value of 70 volts a lot in this section of the regs, and it may throw you off at first because what we normally refer to as touch voltage is 50 volts. Now that's the value of voltage that in theory won't kill you if you touch it. So why are we allowed a so-called touch voltage of 70 volts in an EV charging installation? Well, the reason is that 50 volts touch voltage is the value someone could experience from hand to hand with current passing across the chest and through the heart. Generally, we'd expect a person receiving a shock from a charging electric vehicle to get that shock from a hand to a foot, as these are the parts in contact with the car and the earth. This path will generally have a higher resistance and the current will be less likely to pass through the heart, meaning a slightly higher voltage could theoretically be tolerated. So how does the device spoken of in this regulation achieve this monitoring? Well, some further information is found in the annex to this section in A722.4. I'll read this from the corrigendum as there was a slight mistake in the original. Now bear in mind when we read pen fault in this paragraph, we're talking about the loss of that combined neutral and earth conductor. Regulation 722.411.4.1 indent 3 describes a device that measures the voltage between the circuit protective conductor of the electric vehicle charging equipment and earth. During a pen failure in the supply network, the neutral of a TNCS supply is no longer considered to be reliably connected to earth, and a device that measures the voltages between the following points will fail to provide equivalent safety to the device described in Regulation 722.411.4.1 indent 3. Indent 1, the circuit protective conductor and neutral. Indent 2, the circuit protective conductor and the consumer's main earthing terminal. So this monitoring device can't just be connected across the conductors mentioned in those two indents there, as it wouldn't reliably measure the voltage from CPC to earth. So what's the solution? Well, let's just have a look at part A of A722.4, as part B is concerned with a three-phase system. It reads, suitable arrangements include measurement of the voltage between either A, the circuit protective conductor, and a suitable measurement earth electrode. So this method requires connecting to an earth electrode so the device can measure between the CPC and the earth, or what we can sort of think of as the hand and the foot. So if we're back to using an earth electrode, does that mean that we've just gone full circle and now we've got all the issues that come with driving an earth rod blindly into the ground? Well, no. The earth electrode here is a reference electrode. It's not there as the main earth connection of the circuit. So that means that a much shorter earth rod can be put into the ground to tell the device what the voltage of the earth is in that particular position. The paragraph in A722.4 goes on to outline some precautions of the electrode positioning to make sure the voltage on the electrode isn't affected by any bonded building metalwork entering the ground near the rod. For many domestic properties though, you'll find plastic incomers for the gas and water, and very likely no structural steelwork either, so it's not too much of a problem. The Indra Smart Pro charger allows you to use this method and has a terminal for connecting the reference earth electrode, as you can see here. So it's simply a matter of driving the earth reference electrode home near to where the charger is installed. Obviously, a measure of caution still needs to be taken when driving an electrode into the earth. And the longer the rod, the better. However, it can be achieved with a shorter rod, as long as you achieve a resistance of 600 ohms at 1 meter. As this connection is not an earth, an equipotential bond, a CPC or a functional earth is defined by BS 7671, Indra recommend connecting with either a 4mm or 6mm solar cable, which is generally black in colour. It's also important to keep the earth reference away from any existing connections to the greater mass of earth, such as may be found near the incoming supply, or any extraneous conductive parts. The reason for this is that under fault conditions, the rising voltage on these items can cause a rise in voltage on the reference electrode and reduce the effectiveness of the charger, monitoring the potential difference between the CPC and the earth. Again, this shows how the Indra Smart Pro charger is a cut above the rest, as it actually will disconnect the charger at 30 volts instead of the maximum permissible 70 volts from BS7671. This helps to mitigate the effects of this voltage rise on the reference earth under fault conditions. As you normally would with an earth rod, securely connect the cable to the clamp at the top of the rod and pop the termination into a suitable enclosure. However, there are some circumstances where it simply isn't feasible to use an earth reference electrode. Maybe you can't confirm the lack of underground services which could become damaged, or you'd have to drill through perhaps a huge slab of concrete or pavement to get to the general mass of earth. There is another way of meeting regulation 722.411.4.1, and unsurprisingly, the Indra Smart Pro will accommodate this method as well. Indent 4 reads, protection against electric shock in a single phase installation is provided by a device which electrically disconnects the vehicle from the live conductors of the supply and from protective earth in accordance with regulation 543.3.101, indent 2 within 5 seconds in the event of the utilisation voltage at the charging point between the line and neutral conductors being greater than 253 volts or less than 207 volts. The device shall provide isolation and be selected in accordance with table 537.4. Equivalent means of functionality could be included within the charging equipment. Closing or resetting of the device shall be possible only if the voltage between line and neutral conductors is in the range 207 to 253 volts RMS. So this is a slightly simpler approach that doesn't require a reference earth electrode and relies on the measurement of the voltage between line and neutral. Remember, if there's a pen fault and the combined neutral and earth conductor becomes disconnected, then the voltage on the neutral will rise to be around the same as the line conductor, meaning that a voltage measurement between the two will be much lower than when a healthy supply is maintained. So if the voltage between line and neutral goes above 253 volts or below 207 volts, then the device will disconnect the supply to the circuit it's connected to. The regulation says that this device can be incorporated into the charging unit itself, and this is exactly what's been done on the Indra Smart Pro charger. The really clever thing about this charger is that you can set it to meet the requirements of all of these indents as long as it's on the correct setting. If you're using it to comply with indent 4, then you'll need to set the switch to mode B. Personally, if I was installing this charger, I'd always go for the reference earth electrode option wherever possible, but in situations where it may not be, I'd then fall back on the indent 4 solution. The reason being that indent 4 infers a pen fault and a raise in the voltage between the car bodywork and the earth, whereas the indent 3 option actually measures it at the 70 volts value. It's worth noting as well that both of these approaches state that the protection must disconnect the live conductors, so that's the line and the neutral, as well as the protective conductor, which is fairly unusual in the wiring regulations, but makes perfect sense when you consider that it's the protective conductor that's causing the body of the vehicle to become live in this instance. Another thing that sets this charger apart from others on the market is the management of nuisance tripping. Many devices will comply with indents 1 and 2 from regulation 722.411.4.1, as well as installations with TNS or TT earthing arrangements. However, because of the way they offer pen fault protection by complying with the requirements for indent 4, they can be overly sensitive to natural voltage fluctuations. For example, on a brand new housing estate, the first houses that are built and connected to a new transformer may have a slightly higher voltage than usual. Then a small natural fluctuation will be seen as a pen fault, and for many products on the market, they'll disconnect the charger. Another example of where this could happen is if there's a high presence of renewable energy sources locally, such as banks of solar PVs or wind turbines, either on the property or close to it. The Indra Smart Pro takes advantage of the fact that the reg allows for a period of 4 seconds to pass before the device operates in the event of a pen fault. Taking advantage of this period allows the device to filter out those brief high voltages that would disconnect chargers from other brands. This also has the advantage that in the event of a proper pen fault, the charger has a soft shutdown function, which means that it will turn the charger off in a controlled fashion. It's a bit like the difference between shutting your PC down properly versus turning it off at the wall. Shutting down properly allows the computer to protect itself and ensure the continued smooth running of the electronics. The same principle applies to this very clever charger. For this video, there's just one final thing to consider, and that is the risk of simultaneous contact. This is one area that's taken a little bit of a backseat in the world of EV charger installation. However, it is still very, very pertinent. The problem arises when you have 2 metallic items connected to the supplier's earthing arrangement that's been installed outside the equipotential zone. The classic example is maybe a tap and a light fitting. If there's a rise in potential between these items, then it's possible to get a shock between them if you touch both at the same time. Now obviously there's a very real possibility of this happening if you have the car charging on the driveway and there's an outside tap nearby. If you've installed the Indra charger with the earth reference electrode and the switch in the back on mode A, thus complying with indent 3 of the reg that we've looked at in this video, then this will prevent any shock from occurring in this instance. If you've installed the charger under circumstances where regulation 722.411.4 does not apply and you're using mode A, or if you're using mode B without the earth reference electrode, then the risk of simultaneous contact must be managed locally, perhaps by inserting a piece of plastic pipe into the pipework supplying the tap to ensure that the bodywork of the car and any local exposed or extraneous conductive parts of the installation cannot be touched simultaneously. So there we go. In this video, we've looked at the importance of complying with that critical regulation regarding PME arrangements in electric vehicles and whether to use mode A or mode B in the charger, depending on the local circumstances. We've also seen how the Indra charger will reduce the incidences of nuisance tripping and the importance of removing the possibility of simultaneous contact between the EV and other earth accessories in the area. In the next video in this series, we're going to look at the connection and commissioning of the charge point to make sure that it's set up for the best possible customer experience. All that remains in this video is to say thank you very much for watching.